Hello class. So let us look at some review questions for exam 23. Now in the figure below here, line L is perpendicular to line M. Now, then here what we end up getting is line L is perpendicular to line M. That means we have, this is the right angle. And line K is perpendicular to line B. K is perpendicular to line M at B, so that means this is also right angle. And then line L, M, K are same plane. Then which statement is the first step in the indirect proof to prove that L is parallel to K? Now you see, key word here is indirect proof, and then the proof statement is this one: L is parallel to K. In indirect proof, what we want to do is whatever we want to prove, that has to be negated. So L is parallel to K, so our answer should be L is not, just put down the word not, parallel to K. Then that becomes our answer. Assume that L is not parallel to K. Choice D becomes therefore our answer. Number 2. So here, in fact, this is the indirect proof question, which we actually have to write down the proofs. Notice that ABC is not isosceles. That's the given. But what we need to prove is that the altitude BD, it would not bisect AC. Now, then what we're gonna be doing is this. It's gonna bisect AC. That is our proof statement. So what we're gonna do is we're gonna do the opposite. First, let us try to write down the givens. And then I'm going to write down the word statement. And then the regions. Alright, let's look at the first one. The first one would have been given, which is ABC is not isosceles. So ABC, or triangle, is not isosceles. In fact, another thing is this: altitude BD is also condition, also that's given. It is an altitude. And then the reasoning is given, as we all know. How about second step? Second step is, since the proof statement is it will not bisect AC, so let's assume that BD bisects AC, and that will be our assumption. Now, since it's not drawn, let me just write that down. And then I'm going to assume that that's D. Now, since BD bisects AC, then we get to realize that this line segment must be equal to that line segment. That's based upon our assumption. So step number 3 here would have been this one. So AD must be congruent to DC. Why? A bisector cuts a line segment, because this is what we're looking at, line segment in two congruent parts. Alright, now statement number 4. And notice that BD is it was an altitude as it was given, so we get angle BD and angle BDC are right angles. Y, step number 5, is the altitude, forms right angle with base. Now, step number 5. But we know that right angles are congruent, so we can say that that right angle and this right angle, they're congruent. So angle BDA is congruent to angle BDC. And all right angles are congruent. Step number 6. And notice that BD is reflexive between two triangles, one on the left and one on the right. So we're going to write down BD is congruent to BD. Reasoning would have been reflexive. Number 7. Then notice that we get to see these two triangles here. The one on the left with the green color and the one on the right with the blue color. Both of them would have been congruent by side, angle, side. So here we get triangle BDA is congruent to triangle BDC. Why? SAS. Then step number 8, you can say that AB is congruent to CB. Why? Because they are corresponding sides between two congruent triangles. We call that CP, CT, C. Step number 9. Then, since those two sides are congruent, we get to realize that triangle ABC is isosceles. Okay, why? Two congruent sides in a triangle make isosceles triangle. Now, but what have we realized? Step number 10, notice that here, step number 9, it says ABC is isosceles, but on the given, ABC is not isosceles. Is it a contradiction? So therefore, what we originally set out to do, assumption, is wrong. Then we have to write down BD does not bisect AC. The reasoning is contradiction. Between number 1 and 9. Alright, so that becomes our proof. Let us look at number 3 for a second. So we have three sides given. Find the perimeter of the triangle formed by connecting the midpoint. What is it talking about? We're talking about mid-segment. One thing about mid-segment is this. Mid-segment is half of its base. That's one thing that which we have to realize in this case. So in any triangle for that matter, if this is a midpoint, a mid-segment, and then given that if this one is x, then this would be 2x. 2 to 1 ratio is always what's given. So I'm going to assume some midpoint here. Let us assume that this is a midpoint to this one, and then somewhere around here. Now, and then I'm going to connect them. Around there. You will notice that since this is 16, its mid-segment here would have been equal to 8, half of that. Since this is 14, half of that would have been 7 over here. Since this is 10, the half of 10, which is 5, would have been right over here. So therefore, what is the perimeter? All we have to do is simply add up these three values. Then our final answer would have been 5 plus 7 plus 8, which is equal to 20. And 20 becomes our final answer. Alright, let's look at number 4. So D is the midpoint and O, and then G is the midpoint. So we get to realize that these are mid-segments right over here. Same thing as the last question. And then they have mentioned that AC is equal to 10 and AT is equal to 18 and CT is 22. What is the perimeter of the parallelogram CDOG? So CDOG. So the red parallelogram is basically what we're looking for. Let us write up the values here. Since this is 22, what do you realize about DO? It must be 11. But since G is the midpoint of CT, this side is also 11, half of 22. Since this side is equal to 10, its mid-segment is 5, and since D is midpoint, that's also 5. Then I guess we are done. Perimeter of this parallelogram is 11 plus 11 plus 5 plus 5. So once you add them up, then we get that's right, this becomes 32. So choice 3 becomes our answer. Alright, let us move on to the next question, number 5. In the diagram below, the vertices of DEG, which is the small triangle inside, are the midpoint of the equilateral triangle. Since the equilateral triangle, all three sides are equal. This side is equal, this side is equal, so is this side. Alright, now, but the perimeter of the triangle ABC is 36. Perimeter is 36. That means each side must be 12, isn't it? Dividing 36 by 3. Then what is the length of line segment EF? EF is, that's basically what we have. Since EF is a mid-segment connected by the midpoint, then it must be half of its base. So we get 6. So 6 must be our answer. Number 6. Number 6 is also same idea in a way that this is the base and then this is the mid-segment. So ratio between mid-segment and then the base is 1 to 2. So we get the equation that I can write it up is 3x plus 1 over 7x minus 3 must be equal to 1, 2, 2. By cross multiplying, then we get 6x plus 2 by crossing these two must be equal to, multiplying the other two, 7x minus 3. Then here we can add 3 both sides and subtract 6x from both sides. Then we end up getting x here, these cancels out, equals 5. X equals 5, but we're not done yet because what we are looking for is VC. VC, as you notice, is the half of this line segment. To calculate that, we can put 5 here. So 7 times 5 minus 3. 7 times 5 is equal to 35, so we get 32 becomes our answer. But VC is the half of that, so we get 16 becomes our final answer. Alright, let us look at number 7. Same idea as before. Here, DE is equal to 6 here. And AC is equal to 3x minus 15. Now, what is the value of x? To find the value of x, we're going to write it up as a 6 over 3x minus 15 is equal to 1 over 2. And when you cross multiply them, we get 12 is equal to 3x minus 15. So here we get, adding 15 to both sides, then we get 3x must be equal to 27. And obviously by dividing both sides by 3, x must be equal to 9. And choice 3 seems to be our answer therefore. Alright, so here DE joins the midpoint. Okay, so once again then this is a mid-segment which is half of the bottom side. Which statement is not true? Is CE half of CB? You see, once you create the midpoint or mid-segment, upper triangle that you see is the half the size of the entire triangle in its length. Not necessarily the area, but in its length. So now, here what do we get? CE is half of CB, which is correct. But we are looking for not correct. DE, which is the mid-segment, is that half of AB? Yes, it is. So that is also true. Now notice that I'm going to go for choice 4 first. In previous questions, perimeter has been always half of the original one. For example, here each side was 6, and 6 plus 6 plus 6 would have been 18, which is half of the 36. Here, even in this one, perimeter of the inside triangle made by the mid-segment is 20, but when in fact original perimeter would have been 40. So therefore, to answer this question, perimeter of the triangle, perimeter of the triangle of the earlier one is half of the perimeter of the big one, which is also true. Except the only thing that's not true is the area. Notice that I'm going to just connect a couple more points. Assume that the midpoint D and then midpoint between A, B is connected, and so is this one. Then you will see that you have 4 triangles. 1, 2, 3, 4. So what you end up getting is this triangle CDB, CDE is 1 out of 4, not 1 out of 2. So therefore, that's not correct, which makes it as our answer. Alright, let's look at number 9. So here we have 2 triangles here, ACB. ACB is this angle. That's congruent to AED, which is this angle. But we want to prove that the big triangle is similar to the small triangle on top. We need 2 pairs of the side, 2 pairs of the angle, at least. That means, wait a minute, we see 1 pair that's given. Oh, that's right. The other pair is angle A. Therefore, these 2 triangles are similar. So let's write it up. So here we get statement, and then the regions. First, we gotta write down the givens. Here it seems like ACB is congruent to AED. Alright, then here that's the given. And how about number 2? That's right. Angle A is congruent to angle A. Why? Reflexive. And in fact, that was the common thing between two triangles. So now, I guess we're done already. Triangle, it says ABC, is similar to triangle A DE by AA postulate. Alright, good. Let us look at number 10 together. Number 10 is also proving that two triangles are similar. Here AB and then BE, they are perpendicular, so we get that's the right angle. And DE and then BE, so therefore that's the right angle. And then angle AFD, which is this dotted angle, that's the dotted angle. And then angle ECA, which is the other dotted angle here. So those are two dotted angles. But wait a minute. Notice the triangle that which we are looking at is ABC. ABC triangle looks like this. Can you see that the dotted angle, either one of them, is not actually one of the vertex angles here? No. Another triangle that I can think about would have been here. Notice that right angles are one of the angles at the vertex, but not the dotted angles. But we're not done yet, because since you know the dotted angle to be congruent to each other, that means this angle DFE, is in fact supplementary to the dotted angle, so is the other one, and hence creating two pairs of the congruent angles once again. And hence we can say that a red triangle is similar to the green triangle that we are looking at. Let's write them up. Alright, statement, and then the reasons. So here we have AB is perpendicular to BE, and then DE is perpendicular to BE. Alright, now, and angle BFD is congruent to angle ECA. Those are all givens. Alright, now, then the second one, all we get to realize is the right angles. Angle B and angle E, angle B and angle E are right angles. Statement is what? Perpendicular lines form right angles. Now number 3, and not only the angle P and E are right angles, now then they are congruent, because all right angles are congruent. Alright, step number 4, we can say angle DFC is congruent to angle ACB. Why? Because supplementary to congruent angles are congruent. Alright, then step number 5, since we set two pairs of the angles at number 3 and number 4, we can say triangle ABC is similar to triangle DEF. Why? AA postulate. Alright, so that was number 10. Number 11. We have two parallel lines, WA right over here, and then CH. Since soon as you realize that those are parallel lines, then one thing that I want you to think about is the z. See? So can you create an alternate interior angle through that? Yes, we can. This angle is congruent to this angle. And second one can be the vertical angle too, or we could use the other angle, W or H. Either way is fine. We just need two sides of two pairs of the congruent angles. Then only then we can talk about the proportion, and then after we set up the proportion, then we can get some sort of cross product going. So let's write this one up together. Here we have statement, and then the regions. Alright, now first one is the given WA is parallel to CH, which is given. Alright, now then step number 2 is this. As soon as you see the parallel lines, we can say angle A and angle C are congruent. It's congruent to angle C because alternate interior angles are congruent in parallel lines. Alright, number 3. We can say WTA is congruent to angle HTC. Why? All vertical angles are congruent. Alright, step number 4. Therefore, since we set up two pairs, triangle WAT is similar to triangle HCT by AA. Now, but we're not done yet, because what we want to do is this. We want to see how these line segments came about. WT is right here, and then CT is this one, and then HT is what, this one, and then AT would have been right over here. Oops, or I'm just gonna, meaning we are looking at a corresponding size of the two similar triangles. So to do that, number 5 would have been this. WT is between unmarked angle and then that. Unmarked angle here would have been H, and then that would have been T. So WT corresponds to HT. That is the same as AT must be corresponding to CT. Now, the reasoning is size and similar triangles are in proportion. Now, number 6. Then and only then we can multiply things here. We can get WT times CT must be equal to HT times AT. In math, actually, we don't. When you write down the proofs, we don't want to write down cross multiplication. But better way of writing it is this: product of means is equal to product of extremes. Alright, so that is our proof. Alright, so we're gonna stop here, and then we're gonna continue in part 2. I'll see you soon.